Steve Charlton, Steve Charlton, Vice President of Heavy Duty Engineering at Cummins, Inc.
So this is the 2010 ISX15 engine, and we're looking at the left side of the engine, or the air handling side of the engine. Here's the variable geometry turbocharger, mostly carryover from 2007. The aerodynamics of the compressor and turbine wheel a little different. Here's the electric actuator. So this is controlled automatically by the ECM. Here's the variable geometry turbo. The gap here can be modulated continuously by the actuator, again under the control of the ECM. And it will move continuously during operation, optimizing fuel economy and optimizing emissions so that we continue to be compliant. This is the dosing injector. This injector here is water-cooled. These two lines are coolant. It's used to regenerate the after-treatment device. So we inject a little bit of diesel fuel occasionally. We do this infrequently, but now and again we have to. The hydrocarbons then condense in the evaporate in the exhaust and get oxidized over the DOC, producing heat, which regenerates the soot that's in the after-treatment. The only other thing to point out on this side of the engine is the EGR system. So here you see the exhaust manifold. This is where we take off the exhaust gas for emission control. Then we cool it. I'll just move over to this side. This is a heat exchanger. This is a Shallon tube stainless steel heat exchanger. So the exhaust gases are cooled, and by the time they get to here, they're running at about 150 Celsius, down from maybe 500 Celsius at the other end. Bring the EGR around. We control the flow rate of EGR with the EGR valve. We measure the flow rate of EGR, and then we take it back around to the intake system. So I'll pull the engine around, and we'll show you the XPI fuel system. First of all, here's the exhaust gas that's been cooled and metered, being brought back into the intake air. This is the intake air coming from the charge air cooler into the new log manifold, carefully designed using computational fluid dynamics, so that we get a clean airflow into the engine and uniform mixing and distribution of EGR and air. Now we'll talk about the XPI fuel system. This is the high pressure pump. This will generate pressures in excess of 2,200 bar, 33,000 psi. It's gear driven from the front of the engine. The high pressure fuel is taken up to the rail. Here you see the fuel rail, and you see the individual lines that take the fuel to each of the cylinders. If we move around here, this shows you the fuel being transferred from the rail down into the high pressure connector, through the cylinder head and into the injector. You'll notice the volume in the injector, that's where we hold pressurized fuel. And then when we fire the injector electronically, the pressure is relieved from the top of the needle. The needle will lift and will inject high pressure fuel into the cylinder. And this is the combustion chamber that you see here. I think that covers most of the features.
One thing, there's a camshaft missing.
Yeah. The ISX07 and earlier generations of the ISX had two camshafts. This version of the ISX only needs one camshaft to operate the valve train. The other camshaft has been removed. That frees up a lot of real estate in the cylinder head, allowing better airflow, and also allows us to reduce the weight of the engine by about 60 pounds. So it's a real win-win.